All right, guys.
I definitely cried. But I'm also an emotional person.
What show is this? All right, guys, so we're going to talk about exponential and log functions. We do those two together because they are inverses of each other. So we'll review both graphs. Again, we graph these with a lot of just transformations. There's no, like, make a table of values and graph your log graph, okay? We're going to look at sort of the base function, the parent function, and then go from there, okay? So first, jot down for me f of x equals a to the x. That's an exponential function. So let's look at one with the numbers. We'll do f of x equals 3 to the x. All right, when you go to graph any exponential function like this, which, do you guys remember, like a is the base, x is the exponent, like this is a familiar format to you, hopefully. You will always start with the 2 points 0, 1, and 1, comma, whatever your base is. Okay, so star these something, make sure you realize those are the 2 points you're going to use every time. So for the one I gave you, f of x equals 3 to the x, I'm going to start with 0, 1, put a dot, and then 1, 3. Two points doesn't really look like enough, but I promise it is. Once you get to know the shape. David, can you put your name? Thank you. So when you're graphing exponential functions, you also always have a horizontal asymptote. For sort of your base function or your parent function, it always starts at y equals 0. When we have transformations and shifts and things happening, that will move, but with the parent function, it's at 0. So I'm going to go ahead and sketch that. Got to get the right color. All right, so then I can draw this graph. The shape of it, as it goes to the left towards negative infinity, it's going to approach that horizontal asymptote. But then it's an exponential function, so it's got exponential growth. It's rising quickly to the right. And that's your basic exponential. So again, every time you're just going to start with 2 points, and then whatever the transformation is, you will do that to your 2 points and sketch your final graph, okay? I shouldn't see, like, 8 points plotted on the graph. I know on the math-based homework there's at least one question where they're like, if you plugged a 2 in or a 3 in, like what would you get for these values? But when you're graphing it on a free response, I don't expect to see like a bunch of different things plugged in, okay? So let's try one. All right, let's do f of x equals 2 times 3 to the x plus 1, and then minus 4 outside of that. We're just throwing lots of transformations at you all at once here. Okay, so before we get to any of the transformations, what are the 2 points I'm going to start with on my graph? 0, 1, and 1, 3. Yes, so those are the 2 sort of parent graph points I'm going to start with. So 0, 1, and I'm going to make my tick mark smaller this time just because of the shifts I have happening. So 0, 1, and 1, 3. If you guys have like colored pencils or pens, they're helpful when graphing these just because we're going to do multiple dots. I'll do them in different colors just so you can see the transformation as we go. Okay, so let's walk through what all of these transformations are. You guys know from what we've graphed so far this year, we start with the multiplication. You sort of do it in the order of operations. So that 2 out in front, what is that doing? What is that? What did it do before if you had a 2 in front of your whatever you were graphing? So if it was in with the x, you would absolutely compress the x values. This is just out in front. What does it do? Multiply the y values. Yeah, so that is a vertical stretch, which really just means multiply y values by 2. So I started with these points 0, 1, and 1, 3. If I multiply my y values by 2, I'll have 0, 2, and 1, 6. So I'm going to plot those dots in blue just so I can see them. So there's 0, 2, and 1, 6 is way up here. Okay. All right. Then I've got a plus 1 up with the x and a minus 4 just sort of at the end there. So what do those mean? What's the plus 1? Okay, so we're going to go left 1. And what about the minus 4? Down 4, good. So guys, I'm just going to count the blue dots that I made. I'm going to count left 1 and down 4. Put a new dot. Left 1, 1, 2, 3, 4. 1, 2, 3, 4. And guys, where does my horizontal asymptote end up? The graph got shifted down 4, right, Connor? Yeah, so your horizontal asymptote is down at y equals -4. That asymptote will always follow the vertical shift. Okay, so whatever your vertical shift is, that's your asymptote. So there's the asymptote down there. Sketch the shape. Can you guys see that okay? Move it up a little. Questions on that? It really is the same kind of transformations we've been doing for a while now. Okay, you just start with your 2 parent graph points and then go from there with your transformation. All right, let's try another one. to y equals 2 times 1/3 to the x minus 2. Okay, I don't really like the 1/3 in there. I don't really want to graph with 1/3. Can anybody think of another way I could write this? 2 times something to something. Like, how could I rewrite this maybe with a different exponent so I don't have a fraction? Anybody know? Yeah.
2 times 3 to the negative x.
Perfect. Yes, that's exactly what I'm looking for. 3 to the negative x and then minus 2. All right, guys, so what are the 2 base points that I'm going to start with now that I've rewritten it? What was your first point, sorry?
0, 1.
Yes, there we go. 0, 1, and 1, 3. Plot those. All right, so we've got a couple of multiplying things to deal with here. So the 2 out in front, what does that do?
Vertical stretch by 2.
Okay, vertical stretch by 2, good. And then what about the negative in with the x? What does that do? I know it's a reflection, but over what? It's saying the x is changing sign, right? It's saying opposite of x. So if your x goes from positive to negative, which way are we?
The y-axis.
Yeah, we're flipping over the y-axis. So reflect over y-axis. What that means is multiply x values by -1. So I'm going to do both of those all in one step. So 0 times -1 is still 0. And then the y value I would multiply by 2, so I get 0.02. X value times -1, so that's -1. Y value times 2, that is 6. So I've got 0, 2. And then I have -1, 6. Are you guys okay with that? With that negative and with the x? Yeah.
Aren't like all fraction bases just like a negative slope?
Yeah, instead of exponential growth, they're exponential decay. Yep, so you should recognize that from the beginning, like, oh, it makes sense that this is going downhill. And if you started with the rule with 0, 1, and 1 base, you'd have 1, 1/3, you know, that be, yep, you can absolutely still do that. Okay, so you really could graph either of these and you get there. Then what's the only other thing I have left to do, guys? Yeah, shift down 2. So what does that make my horizontal asymptote? Yep, y equals -2. Good. Down 2. Sketch your shape. Questions on that one? Don't get overwhelmed by it. Just do it one little piece, one little step at a time. guys. So that's graphing exponentials. Are we okay there? Okay, we're going to do some not graphing, but still working with exponentials. Solve. All right, let's say we have 3 to the x plus 1 equals 81. When your variable's in the exponent, it's a different kind of equation to solve. You can't use your normal methods of solving to figure it out. This, we can make the bases match. Later, we'll get into some equations where you have to use logarithms to solve. This, you don't have to, though. You can actually make the bases match. What base do you think I want to go with on both sides here? 3. Yeah. You always want to go to the smaller base. I don't want to try to turn 3 into 81. I want to turn 81 into a base 3. Okay? So I've got 3 to the x plus 1. Just leave that alone. And then on the right side, 3 to what power is 81?
3 to the 4.
Okay, good. And yes, this would all be without a calculator, but I think you guys can do 3 to the 4th. Once you have the bases matching, you're not canceling out the bases, but if the bases are the same, the exponents have to be equal to each other. So then you can write that equation, x plus 1 equals 4, so x must be 3. Questions on that one? Make the bases match, go to the smaller number. Sometimes you'll have to change both sides, okay? And then just set the exponents equal and solve. Let's try another one. All right, let's do 9 to the 2x equals 27. All right, thoughts on a base here that would work? 3, good. Everybody sees how you can't use 9. I mean, you could with some fractional exponents. It's not going to be pleasant, though. So let's just make both sides base 3. So 3 to what power is 9? Okay. And then that is raised to the 2x. And on the right side, 3 to what power is 27? Third. Okay. Exponent rules, what do I do when it's a power to a power, like on the left side? Multiply, good. So that's really 3 to the 4x equals 3 to the third. Bases match, you can set your exponents equal, and then it becomes a pretty simple equation. Okay. Questions so far? All right. Let's do e to the negative x squared equals, what do I want to do? E to the x quantity squared times 1 over e. Do you guys remember seeing e last year? Okay, so you don't have to understand exactly where it's coming from next. It's Euler's number, and you'll learn a lot more about it in calculus. What you need to understand at this point is that it's just an irrational number. It's a lot like pi. Okay, you're comfortable with that at this point. E is very similar. We'll talk about the ratio and where it comes from later. but you just need to recognize that it's a number. It's not like another variable happening in this equation, okay? It's just a number. All right, so clearly we want to go with base e, right? Okay, so the left side I can just leave alone. That just is e to the negative x squared. Now on the right side, I have some simplifying to do. E to the x squared, what could I rewrite that as? Yeah, e to the 2x, good. Times, how could I write 1 over e so that it's e to something? Good. Okay, we're getting close. So the left side is e to the negative x squared. All right, on the right side, when you're multiplying and you have the same base, what do you do with your exponents? Add them. So this is really e to the 2x minus 1. You with me there? Okay. Now it's okay. Here, let me move it up a little and then. Are you good with the e to the 2x times e to the negative 1? Remember when you had, like, let's say I had a cubed times a to the 4th, right? Because you add, yeah, it's that same rule, just looking more complicated. Right. So then I can just set my exponents equal. So I've got negative x squared equals 2x minus 1. I'm going to move the x squared over. Does it factor? It doesn't. You would need negative 1 times negative 1. Actually, you'd need positive 1, and that's not what we have. So it does not factor. So you need to either complete the square or solve with the quadratic formula. Let me remind you how to complete the square, because do you guys remember how to do that? Okay. So what you want to do, I'm going to bring the constant to the other side. So first, are you guys fine with me just rewriting it this? I just like my variables on the left better, so we're going to move that 1 over, but I'm going to leave some space over here on the left side, so I'm going to move the 1. Okay, what you look at to complete the square, this coefficient, which is essentially your b value, you're going to take that, you're going to divide it by 2, and then you're going to square it. So what do I get when I do all of that? I get 1, right? It's a whole lot of work to get 1. That is what I add right in this spot here. But if I add it to the left side to keep things balanced, I also need to add it to the right side. Okay, what we've done there, now on the left side you have a perfect square trinomial. It's something you can actually factor. It's always going to be x, because x times x is x squared, the sign from the middle, and then the square root of what you just added to both sides. Quantity squared. Okay, you picked that particular value of 1 because it creates this perfect square trinomial. You can actually factor it now. Okay, we'll practice this again and again throughout the year. Okay, solving that then, how do I go about solving this? Square root of both sides, good. So then I have x plus 1 on the left. What do I need to remember on the right side? Good, yeah, plus or minus root 2. So my final answer is negative 1 plus or minus root 2. If you had done the quadratic formula, that is the same answer you would have ended up with. questions on that? All right, how do we feel about completing the square? How many of you are like, yes, I definitely did that last year? About half, okay. All right, good to know. We will revisit. All right, we are now going to switch over to thinking about logs. All right, so the first thing we're going to do is work on rewriting our log as an exponential. So rewrite as an exponential. All right, so I've got log base A of B equals C. We are going to rewrite that as an exponential equation. Again, logs and exponentials are inverses of each other, and we'll look at that when we go to graph logs today as well. Hold on, guys. Okay, guys, so what is the base in this log equation? Not B, A, yeah, the A is the base of the log equation. So the A is the base of your exponential equation, okay? So we are going to have A to the exponent part of it is C, and what it equals is B. So you can just remember, like, what it equals is always the exponent, and you know where the base is, and go with it. That way, you can actually do what's called taking the log of both sides or exponentiating both sides. You just have to be comfortable with moving these pieces around. So let's try another one and make sure you can follow where everything goes. So that was a basic one with no numbers, just so you can see it. So let's do log of 1,000 equals 3. And I know I didn't write a base this time. Does anybody know why I didn't write a base? Connor? Yes, that is 10. That is what's called a common log. So any log base 10 is common log. Just a little side note. That's what the log button on your calculator is. It's actually log base 10. So if you see a log without a base, you need to just recognize, oh, that's base 10. So we've said the base is 10. What's the exponent? 3. And what will it equal? 1,000. Okay, it's nice with numbers because you're like, oh, that makes sense. 10 cubed is 1,000. All right, let's try again. All right, let's do log base 4 of 1 over 64 equals -3. You guys try that one. See if you can write it real quick. All right, guys, what do you think? What is it?
Or negative third equals negative equals 1/64.
Perfect, yeah. 4 to the negative third equals 1/64. Do we feel okay converting that to exponential? Sort of. Give thumbs up, sideways, or down. No, where are we? Okay. All right. Good. Keep going. We cover a lot today, guys. It's a big day. All right, now we're going to solve some log equations using what we know about rewriting them as exponentials, okay? And are you guys doing okay? My classes yesterday were just exhausted. How are you guys?
I'm tired, but this all makes sense.
Okay, that's good. Yeah, are we a little tired today? Was yesterday worse? Yeah, okay. Hanging in there. Mondays are rough, guys. All right, so let's solve. Let's say I have 2 equals log base 5 of x. Okay, so if I rewrote it as an exponential equation, what would it be?
5 squared equals x.
Yeah, 5 squared equals x. Okay, so that's it. 25 equals x. Not bad, right? Okay. All right, let's do x equals log base 2 of 8. Okay, guys, what would it be as an exponential equation? Yep, 2 to the x equals 8. So you can like write out the whole making them the same base, all of that, or can you guys just look at that and tell me what it is? Yeah, even from the very beginning, if you're like, oh, that's 3. Good, that's good. That means you're understanding what's happening with logs, okay? If you can just do that in your head, I am great with that. Okay. Let's do one more solving. All right, 1/2 equals log base 9 of x. Try and solve that one for me. All right, so rewrite it as an exponential. What's it going to be? What'd you say? Sorry. Sure? Okay. 9 to the what? 1/2, good. Equals x. All right, good. What does 9 to the 1/2 mean? Square root. Yeah, fractional exponents are talking about roots. So that means the square root of 9 equals x. So what does x equal? 3. Now, normally when you're solving and you take a square root to solve, you have plus or minus, all of that. There's no plus or minus in this, okay? It's just asking for the base square root, and also when we get to graphing, you'll see that you can't take the log of a negative number, so it can't be negative 3 here. Okay, so x equals 3, that is it. Dion, can you get your math, please? Thank you. All right, so solving, for what we're doing so far with solving, is just convert it to exponential and then solve. All right, we're going to do a little evaluating, which is kind of similar to solving, but you don't have an equal sign. So I'll just give you the log, and you have to tell me what is it equal. So we'll have log base 4 of 64. So to evaluate it, I'm really saying, what does this equal? So if it makes you, like, if it makes more sense to you to say, well, I want to write it then as equals x, that's fine, okay? If you don't want to write that and you're like, no, I got this, I can do it in my head, great. Either way is fine with me, okay? If we do it this way, I have to rewrite it as an exponential. So it would be what as an exponential equation? Yeah. If you're doing it in your head, that's what you're thinking about too. You're going, okay, 4 to what power is 64? So what do you think, guys? 4 to what power is 64? Yeah, so. Or if you just wrote 3 under log base 4 of 64, that's completely fine, okay? You don't have to show me a bunch of work on the evaluating ones. All right, let's do log base 3 of 1 over 81. Evaluate that one for me. Check with your neighbors, see if you guys got the same thing. It was just the multiplying the hard part. All right, guys, is that what you got? -4? If you get stuck, oh, okay, equals x, 3 to what power? 3 to the x is 1 over 81. I know it's negative because it's been flipped. 3 to the 4th is 81. You just got to be thinking through your exponents. You can go through the whole, make the bases match, and set the exponents equal if you need to. But hopefully you'll get to a point where you're comfortable with your exponents. You can just look at it and count. All right, log of 1. This one's gotta become automatic for you, but sometimes you get stuck on it. I hear a vote for 0. What do you guys think? Yeah, if you go through it, you know, if you actually like set up the exponential, 10 to what power is 1? 10 to the 0 power is 1. So you've got to know, like if you see log of 1, you just go, oh, okay, that's 0. Same with natural log. We haven't really talked about natural log much. Does anybody remember what natural log is?
It's like 4.7.
No. It's related to log. So common log was base 10. What base always goes with natural log? There's only one thing, yes, E. Only one thing you can use natural logs for. So little side note for you over here. Natural log is a log with base E. Okay, so make sure you know that. Like, you will never write log base E. If you're doing that, like, nope, definitely not. Don't write that notation. It's got to be natural log, okay? Why the L comes first in natural log, I don't know. It just does. So, what do you think natural log of 1 is equal to? That is also 0. Yeah, because if you go through the process, that would be e to the x equals 1. That is also 0. So those are very good to know. Those need to be quick when you see them. You need to just go, oh, okay, that's 0, and you can move on. Okay. What about, let's do one more natural log one here. What about the natural log of e? Alex, I have a vote for 1. What do you guys think? Yeah, it is. Natural log of e is always just 1. Okay, if you go through the whole, okay, the base is e, and it's going to equal e, that must be 1. Okay. So another one that you'll want to know. And one more evaluating one here. Let's do log base m of m to the 5th. I know it looks weird. Sorry, guys. Any thoughts on this one? Are we raising our hand like this because we think it's 5? Yes, it is 5. Anytime the bases match like this, like the base of your log and the base of whatever's happening here, your answer is always going to be that exponent. There happens to be an exponent there. Okay? All right. We have graphing logs left. That's it, guys. Hang in there with me, okay? Need to like stretch here. Can we do it? Okay, so we're going to start by revisiting what we did at the beginning with our graphing of exponentials. So let's look again at f of x equals 3 to the x. We know we had the point 0, 1, and 1, 3 when we graphed that, okay? So we'll do that one. Purple. There is my exponential graph, right? And we had a horizontal asymptote of y equals 0. You know, from what, 30 minutes ago? You guys are pros at graphing that now, right? So now let's look at a log graph. Okay, f of x equals log base 3 of x. I'm intentionally going with the same bases here to graph these two, okay? So logs and exponentials are inverses of each other. What does it mean if things are inverses? We've done inverses already this year. Yeah.
It looks like not the x-axis, it's the y equals x.
Yep. Yeah, you're reflected across that diagonal line. Good. And we'll see that when I graph it here. What else? What else happens with inverses?
They make a right angle, right?
Maybe. Kind of. I think that's going along with the flipping across y equals x. Yeah.
I guess it's also goes along with x, but like you switch like the.
Yeah, in the ordered pairs, the x and y actually switch. So we know with the exponential, we start with these points 0, 1, and 1, 3. So what points do you think I'm going to start with to graph logs?
1, 0, 3.
Yeah. 1, 0, and 3, 1, which is, you're right, we'll write it under there, base 1. So I'll plot those 1, 0, 3, 1. Exactly, that's what I was going to ask. So instead of a horizontal asymptote of y equals 0, you now have a vertical asymptote of x equals 0. Get that sketched in there. So there's my graph. And if I were to draw in that line y equals x, you guys see how, I mean, my hand-drawn graph, but decently, they're reflected across the line y equals x. Okay. So we're going to graph these essentially in the same way that we graphed exponentials, but you just have 1, 0, and base 1 to start with. But the transformations are all the same idea. So, again, for your log graphs, what you need to remember is that you have the point 1, 0, base 1, and you will have a vertical asymptote, okay? So let's try one. So we're going to have f of x equals log base 2 of x plus 3 minus 1. And again, guys, if I go too fast or anything, you need me to go back up, just let me know. All right, guys, do you want to try it on your own? No, I'm seeing some head shaking. No, okay. So your 2 points, remember, are 1, 0, and base comma 1. So what's the base in this one? 2. Okay, so I'm going to start with 1, 0, and 2, 1. All right, and then I've got some shifting that's happening here. Where's my graph going? Yep, left 3, down 1, okay? So I'm just going to take each dot and count left 3. 1, 2, 3, down 1. Left 3, 1, 2, 3, down 1. where is my vertical asymptote going to be? Negative, what'd you say?
2,
Ah, close. What do you think, Alex?
3.
Yeah, -3, so you're close. It's always going to match the horizontal shift. So remember with exponentials, your horizontal asymptote matched the vertical shift. Here, the vertical asymptote matches the horizontal shift. I know that sounds tricky when you say it out loud. But if you shift left or right, that shifts your asymptote as well. And so there's your graph. And again, that's all I need is 2 points, okay? We could talk about the y-intercept and all of those things, but I just want to see you get the idea of the shape, the 2 points, where we're going. Questions on that one? All right, guys, one more in your notes. All right, f of x equals 3 log base 4 of negative x minus 1 plus 2. This one's got a lot going on. I will help you. Okay, first thing, we need to rewrite this. Because of that weird negative inside with the x, we have to do a little work. So I'm going to rewrite this. F of x equals 3 log base 4. That all stays the same. In here, you need to factor the negative out of it. So I've got this bracket, and then I'm going to say negative, parentheses, x plus 1. And then outside of that is still plus 2. You have to do that so that you can isolate what the negative is doing as far as the transformation, and then you get the proper shift. Because looking at the red one, am I going left or right? Left. In the original equation, doesn't look like, it looks like it's a shift right. It's not, though. You have to write it in that factored form. Okay. It's pretty loud. Okay. So I'm going to start with my 2 points. I don't know for sure what that was, guys. Probably. I mean, I know there's storms today, but that didn't sound like it also didn't sound like the normal garbage either, so.
Maybe we'll go like this one.
Oh.
Maybe it was. Okay. Well, we're fine, guys. Don't let that disrupt our graphic, folks. Come on. All right, so I start with 1, 0, and what's my other point going to be? 4, 1. Okay. There's a ton going on in this equation. Don't let that scare you, okay? You don't have to do it all at once. You do one little step at a time. So I'm going to plot 1, 0. I'm going to do 3, 4, 1. Okay. Step 1. 2 dots. Good work, guys. Okay, what do you think I have to deal with next? Okay, the vertical stretch, the 3, and what else could I deal with at the same time? The negative. Okay, the vertical stretch I think we're more comfortable with. Everybody good? Vertical stretch by 3. That means multiply your y values by 3. So 1, 0, the 0 would still be 0. 4, 1, the 1 would now be 3. I didn't do anything with the x's yet. Leaving those blank for now. We okay there? All right. The negative that's in that messy middle part with the x, what is that negative doing? What? It's flipping something somewhere, but what? I saw this, yes, this is happening, okay? It says negative x. Your x is changing sign, guys. It's going from positive to negative. So that is a flip over y-axis. Which again just means multiplying those x values by a negative 1, okay? So 1, 0 is now negative 1, 0. 4, 1 has become negative 4, 3. So I'm going to go ahead and plot those. All right, so negative 1, 0. I think you can see it with those dots, like, oh, they got reflected over the y-axis and it stretched vertically. Like, you can kind of start to see that. And then we have our final step here. We have to shift. Where am I shifting? Left 1, up 2. So I just take the blue dots and I count left 1 and up 2. I need more tick marks. So left 1, up 2, left 1, up 2. All right, and I need my vertical asymptote. Remember, it matches your horizontal shift, so what is the vertical asymptote? Vertical. Did I say vertical shift? Horizontal shift? Negative 1. Yep, so x equals negative 1. So there's your asymptote. And then that's not real pretty, but you get the idea. There's that. Okay, questions? Okay, I know that's a lot of information today. And how many of you are logs like really pretty new for? A few of you. Okay, some of you guys remember a decent amount of the logs from last year? Okay, all right. We actually have time today to do some practice together. So we're gonna play what's called the bluffing game. I need you guys to reach around in your desk. You should have a little whiteboard. I think some of the desks in the back don't have that. All right, so reach in your desk. You Anybody else? Okay. Okay, and you guys need pens too, right? Yeah. Okay. I'm just going to give like a stack to your row down, see if you can find one that works. Oh, you guys when you're talking down. Markers that like that for here. Did everybody find at least one marker that works for them. Yes, we had success with our markers. Okay. Okay, guys, so the way the bluffing game works, I will split the room in half, so there's just two teams, which are not equal, so I'll do a little shifting here. But what I'll do is I'll say, okay, this side of the room, this is your question, and I'll put it on the board, and you work on it on your board. And then I say, okay, stand up if you know the answer. If you don't know the answer, you can still stand up, because how many of you are standing is how many points the question is worth, okay? So if you don't know it, you can risk it and just stand up and go, yes, I know the answer. I can call on anyone who's standing. Okay, so it's a risk if you're like, I don't really know it, but I want points for my team. If the person misses it, the other side can steal it for half the points. Does that make sense? Okay, so let me count. How many do we have? Okay, we'll do, you guys angle back to you. You're on this side, okay? And then here, Connor, you're on this side of the room, okay? All right. So I'll put a question up, and you guys try to do it, and we'll see who gets it. All right, let's start wrapping. I have to do these too. All right, so everybody do it, and then I'll tell you which side. So my teams will be window team and door team. Super fancy. Hello. Yeah, go ahead. And guys, I promise too, I won't like look at your boards and be like, you're standing and you don't know it, I'm gonna call on you. Like, I won't do that, okay? I won't try to catch you. Yeah, and you can just kind of pay attention to what we're doing. Okay. You ready for me to pick a side? All right, let's go window side. So just stand up. You think you got it, or you want to bluff? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Who you call on? Matthew, let's see. Just turn your board around. Let's see if we got it. Oh, yeah, we have 2 Matthews. I'm sorry. So many Matthews. Yes, they got it. All right. I'll draw it for you just to make sure we see. Very, creatively named the window team and the door team. So you start with your 2 points. We flip over the x-axis and multiply by 2. So we're here, and then you go left 1 down 2, left 1 down 2, over there, and left 1. Okay. Yes? Did we feel okay with that one? Kind of, yes, maybe. Okay, let's try again. We'll do another graph here. I feel like I gotta stick with another log graph so that it's equal. Let's do negative log base 4 of negative x plus 2. Question. Door side, are you guys ready or not quite? See some markers still moving, so we'll give you another minute.
Okay.
Yeah, you can't see it very well.
My marker is slowly moving.
Yeah, there may be we have to have like a marker donation competition at some point. I did that with like tissues one year, like 7 years ago, and I still have tissues.
Yeah, I
So.
feel like
Okay, door side, stand up. No, or want to pretend you're no. Either way. Nine points available. Let's see. Excellent. Yes. Good. All right. Close game. All right. Again, real quick, let me just go through it to make sure we got it. The double negatives kind of make this one a little tricky. So I know I start with 1, 0 and 4, 1. You have a negative out in front and a negative in with the x. That means you're flipping over both the x and the y axis, okay? So if you started with the point 1, 0, that's now negative 1, 0. And 4, 1 becomes negative 4, negative 1. Okay, so we're over here. Here, and then we get to shift everything up. And your vertical asymptote, there was no horizontal shift, so it's still just at x equals 0. You just flipped over it. Okay. All right. Let's graph something else. Let's graph an exponential here. All right, try that one. Don't let me trick you. you guys ready? Or? All right, let's go window side again. Stand up if you think you got it, or you'll walk this side. 1, 2, 3, 4. Yeah, you're up or you down? You're down, okay. All right, Alexa. That's good. Thank you for listening. Okay, I think I said 9 points, right? Yeah. All right, let me just go through it again. Few tricky spots on this one. We know we start with 0, 1, 1, 2. I've got a negative out in front, and I have a negative up here, which you have to factor out, okay? You do have to think about that, so the shift is actually right 1 at the end. So if I'm starting with the points 0, 1, and 1, 2, that -3 out in front, that multiplies my y values. -6. The negative with the x just multiplies your x's, changes their sign. Okay, so I've got 0, -3, -1, -6, and then I have to deal with that shift. So I have to go right 1. And my horizontal asymptote, there was not a vertical shift, so it stays at 0. All right, we're doing okay with that, guys? Okay, I gotta give the windows or the door side another shot here. We'll do one more graph because I feel like that's the only way to keep it even, keep it fair. All right, let's do -2 times 1/4 to the x minus 3. Oh, I gotta graph that too. give you another minute here, and then door side, you guys need 10 points to tie. All right, door side, let's stand up. Nine, 10. Okay. All right, Jeff, let's see. That's like way off. Good job. Nice work. Ah, you guys tied. Good work. How many of you were faking on that one? So, a lot of blessings. Okay, I'll try and go through this real quick. We're about out of time. I thought through it like that, just, I don't know, it just makes more sense to my head, but it doesn't matter. You certainly don't have to do it that way. You have to flip over both, stretch both, and then go down 3. So I ended up over here at like -1, -11, and at like 0, -5, I believe. And then your horizontal asymptote was at -3. If you left it as 1/4 and did it, that's totally fine too. Okay. All right, guys. Homework is on math space. Sign today, due tomorrow. Okay. All right, and good work. You made it through a lot today.